Hi guys, welcome to my channel Dreams Chemistry. So in this video we are going to discuss about the first chapter of class 12, that is solid states. In this chapter, before going to this chapter, we just need to tell you something. So we have learned about a word called fluid, right? So what do you know about fluids? Fluids are those compounds which can flow. So in general we have two states of matter which can flow. Those are gases and liquids. So gases and liquids in general, they are also called as fluids because they can flow. So this flow nature of this gas or liquid is because of its intermolecular force of attraction. In general we call it as interparticular force of attraction also. This interparticular force of attraction in cases of gas and liquid is less when compared to solid. That results in solids being a rigid compounds or rigid substances, which makes solids a rigid substances, hence they cannot flow. But in the microscopic level, what we have observed is solid composition or the particles of solid, when are observed in a closed nature, they start to oscillate. So they start to oscillate left, right in their mean position. That means if we take its particular position, they sometimes go slightly towards the right and sometimes towards the left also. That making them vibrate in their mean position. This oscillation of particles of a solid matter on both direction makes them to have a wide range of applications. Like for example, carbon nanotubes. So you have watched, I think you might have watched Avengers Infinity War, where the Iron Man says it's nanomaterials, right? When he first comes across with the Thanos man. So these nanotubes have a very strong property which makes them very stronger when compared to other elements such as metals, like for example aluminium or copper, but they are very less weight. That means they are light in nature but they are stronger because of this particular nanotube properties or nanoparticle properties. So this makes a solid having a very wide range of properties also. So now we will now discuss about the solid state chapter. So a solid has a particular number of characteristics which is quite different when compared to gas or liquid. So what are those properties? So if we say that the first property is they have definite mass, volume and shape, right? They have definite mass, volume and shape. And the second point, they have intermolecular force of attractions at a very high range. They have very high intermolecular force of attraction and less intermolecular distance. They have a very less intermolecular distance. The intermolecular distance of solid particles are less, but their intermolecular force of attraction is more. And further, what we have observed is they oscillate among their mean position, right? They oscillate among their mean positions. The particles oscillate among its mean position. And the next point is they are rigid and they cannot be compressed in some shapes or matters. They cannot be compressed. In general we call it non-compressible. So these are the 5 characteristic properties of solid. That is, first one, they have definite mass, volume and shape, and they have a very high intermolecular force of attraction between the particles, and they have a very less intermolecular distance. And next, they have particles oscillating among their mean position, and the last point is they are rigid and they are non-compressible. So these are about the characteristics of a solid. Now how will you classify these solids? Because depending upon these properties is solids are classified into 2 parts or 2 types. Those are crystalline solids and amorphous solids. Solids are classified into 2. One is crystalline solid, the other one is amorphous solid. One is crystalline solid, the other one is amorphous solid. These 2 solids have a very wide range of different properties among themselves. So why is this different properties arising? So for that we need to know about its definition. So what is a crystalline solid and what is an amorphous solid? What we have observed in the microscopic level is crystalline solids are also made of solid particles. We know that it is a solid, right? So those particles, if you observe in the microscopic level, let us say this is a particle of crystal, or let us say this is a small crystal of a crystalline solid. It is a small crystal of crystalline solid. So this small crystal is arranged in a definite manner in 3 dimensions. So if we go across this shape, so it is arranged like this, one over here, one over above the plane, and one in front, and one in the backwards. So this arrangement, if we know a particular composition at one point of a crystalline solid, we can clearly depict the composition of the particular crystalline solid in the other place, because we know that they have a similar composition at different parts, now like this. Okay, so this makes them having a long range of order. So what is this long range of order? So this long range of order is said as the ordered arrangement of this small crystal, which is constituting a crystalline solid, is of a long range. That means we have multiple small crystals of same size, same shape and same volume arranged in 3 dimensions for a long range of order, and those are called as the crystalline solids. Whereas in case of amorphous solids, this long range order is not to be found. That is because if I say this is a shape of a small crystal of amorphous, the other next to it will not be the same. It might be like this, or it might be like this, making them have a different range of particles in a different order. So therefore they have a small range of order. Amorphous solids, they have small range of order of particles constituting them. And further, we call amorphous from a Greek word called amorphos, which means no form. That means amorphous solids have no different form of shape. So depending upon these long range order and short range order, small range order, short range order of crystalline and amorphous solids, their properties are explained. So which are the properties which explain these differences between these two are? We'll go one by one. The first one is melting point. So the differences are, first one, melting point. So this is for crystalline solid and this is for amorphous solid. So we said that crystalline solids have a long range order, right? So because of its shape being similar in all direction, what happens is all the small crystals start to melt at a particular temperature itself. Therefore, they have a very sharp melting point. Crystalline solids melt sharply, that is at the exact particular temperature, they start to melt and they flow. But in case of amorphous solid, because of its different shapes or irregular shape, they have broad range of melting point. So they have a broad melting point. That is because they first on heating get softened and then start to melt and then they start to flow. This all takes place in a long temperature range. Therefore, they have a broad melting point. They have a broad melting point. In case of for the shape, crystalline solids have a definite shape. As I said, they have particular geometry, and whereas in amorphous solids, they have irregular shape. They have irregular shape when compared to crystalline solids. Next comes is the isotropic effect. So what is this isotropic effect is? So isotropic effect is a particular property depending upon its mechanical, electrical and refractive index properties. So if a substance has a particular these 3 properties is same along in same directions, then they are said to be isotropic. That is our amorphous solids. Amorphous solids have same refractive index, same mechanical properties and same electrical properties in a direction. Therefore, it is called an isotropic solid. Whereas the crystalline solids have different mechanical, electrical and refractive indexes at different positions. Therefore, they are called as anisotropic solids. They are called anisotropic solids. Next, the range of order. They are called long, they have long range, whereas amorphous solids have small range or short range of order. Next comes the heat of fusion. This heat of fusion explains the temperature at which, or the temperature range of this crystal solid is getting liquefied. So crystalline solids have a definite heat of fusion. They have definite heat of fusion. That means crystalline solid when it completely converted to liquid. But in case of amorphous solid, when they are heated, they form powdered salt. Okay, they are also called as a supercooled liquid. Now for this property, they don't have a heat of fusion, no heat of fusion for amorphous solids. Next, for this, next point is nature of the solid formed. Nature of the solid formed by crystalline or amorphous solid. Crystalline solids are called true solids, whereas amorphous solids are called supercooled liquids, because they form a molten liquid when heated. Okay, so these are the 6 properties which define the difference between crystalline solids and amorphous. Apart from this, we have also found some of the amorphous solids acting as a crystalline solid. Those are called polycrystalline solids. Those are called polycrystalline solids. So if some of the amorphous solid acts as crystalline solid, then those are called polycrystalline solids. And even though these amorphous solids have an isotropic nature, they have found to be having a various uses in day-to-day life. Like for example, gases, rubbers, plastics. They are made up of amorphous solids. And further, the silicon. Right, we generally use amorphous silicon. The amorphous silicon which we use in satellites to convert electrical sunlight to electrical energy is made up of photovoltaic cells. That is nothing but the amorphous silicon. Those are the amorphous silicon which we use to convert the sunlight into electrical energy for satellites. So this is about the classification of solids and the properties of your crystalline and amorphous solids. Thank you for watching. Please do subscribe my channel Creams Chemistry for more updates on the new videos. Ring the bell icon. Share this video, like this video, and comment down if you have any doubts. We'll discuss the doubt in the next class.